in order to graph this, I have to think of two good values to plug in. And in order to do that, I'm going to choose 1 and the base. Those are the best two, 1 and the base. So here we go. Make a table. I'm going to plug in 1, and my base is 6. When I do that, I get log base 6, 1, which is saying 6 to the what power is 1, which is 0. And then I'm going to do log base 6, 6, which is saying 6 to the what power is 6, which is 1. So I plot the dot 1, 0, and I plot the dot 6, 1. Now you should also realize is there's an asymptote. Logs have a vertical asymptote because logs can never have outputs of 0 or negative. Are you okay with that? You can never put a 0 into a log or a negative. So this is asymptote. And so the graph comes up next to that and does a sharp turn, which doesn't that look like an exponential on its side? So you always have an asymptote at 0 because you cannot put in zeros or negatives. And then you plug in 1 and the base. And you got 2 dots and you can graph. So for this one, I'm going to plug in 1 and the base. And won't this 5 do a vertical stretch? So watch what happens. I'm going to plug in 1 in the base. So make my table. Plug in 1 and the base, which is 2. That gives us 5 times log base 2, 1, which is 5 times, 2 to the what power is 1? Isn't that 0? So it would be 5 times 0, which is 0. And the second one is 5 times log base 2, 2, which that means 2 to the what power is 2, which is 1. And 5 times 1 is 5. So I have a coordinate 1, 0, and I have a coordinate 2, 5. And don't I have a vertical asymptote at the y-axis? So it looks like this, a really ugly line, all messed up. Okay, it looks something like that. Do you see how it was stretched by a factor of 5? And the 2 is how I found my values. Now, for this one, could I probably plug in 4, which would actually come out nicely maybe? Yeah, but we don't have to. 2 dots are good enough. So this one's going to be a little bit trickier because in order to plug in 1 and your base, what you really need is this to equal your 1 and your base. So what you have to think about is x plus 3 has to be equal to 1, and x plus 3 has to equal to your base, and your base on this one is 10. So now you can't figure that on your head maybe, but if you don't want to, you just minus 3 over, and you get x equals negative 2, and when you minus 3 over here, you get x equals 7. What that means is, if you put negative 2 right here, won't you get 1? If you put 7 right here, won't you get 10? And from that, it'll be nice numbers when you plug it into the table. Watch and see. So when I plug in my table, I'm going to plug in negative 2, and I'm going to plug in 7. So when I plug in negative 2, I get log base 10, negative 2 plus 3, which is log base 10, 1. And when you think about that, that's saying 10 to the what power is 1, which is 0. Next one, I do log base 10, 7 plus 3, which is log base 10, 10. What is that saying? That's saying 10 to the what power is 10, which would be 1. So we put 2 dots on here. We're going to put a dot at negative 2, 0. And we're going to put a dot at 7, 1. There's 2 dots. Now the funny thing is, isn't the asymptote normally the y-axis? But with this, doesn't this say you got shifted left 3? You think about that. Isn't there the opposite there? So really isn't that h saying I'm going left 3? So what the asymptote's going to do is the asymptote actually got pushed over left 3. That's something you have to be aware of, because all logs have an asymptote right here normally until it got pushed over. All right, and then here's your 2 dots from your table, and you can now make the graph. It's going to go up against the asymptote and do a quick turn and go like that. And that right there would look like a sketch of that logarithmic function. Again, it's a little bit tougher when you have to change your values besides just using 1 in the base. All right, we're going to graph this one here. What you notice different is I have a -3 in front and I'm at ln. Now let's think for a second. If I have the -3, it's fine, but ln is log base e x. So the base is e. So what numbers will I plug in to my table? Well, hopefully you notice you're going to put 1 like always, but you're going to put the base, which is e, and e is about 2.7. All right, when we plug in 1, we have -3 times log base e 1. Remember, e to the what power is 1? That's going to be 0. So really, this is -3 times 0, which is 0. So I have a coordinate at 1, 0. Next, I'm going to plug in e. So -3 times log base e, e. And remember, e to the what power is e? You understand, hopefully, that is 1. So that's -3 times 1, which is -3. Now the question is, I have a coordinate e, -3. E is 2.7, so I'm really going to go over to 2.7 and then go up 3. So I have a dot right there. So that would be right about there. It's approximate. Oh, I made a mistake. Ooh, what is that mistake? That is a -3. Be careful, that's a 0, that's a -3. So really, I'm going to go over 3 and down, sorry, over 2.7 and down 3. So that's going to be right there. I have my asymptote like usual right here. There's no horizontal shift. So my asymptote's still right there. Now what's a little different here, do you notice it looks like it's going down like this? Well, wouldn't that be a negative? Don't normal logs look like that? Normal logs look like that. But since it's a negative, doesn't that mean we flip it? We flip it. And so it actually does going to have this look that goes like this and then turns like so. All right, so understand if you have a negative in front, it's going to be a little upside down because most logs go like this. Negatives will flip, so it's going to look kind of like upside downish.